In this presentation, we'll look at object-oriented programming. It's a way of managing complexity and minimizing code duplication. So what is a class? Up to this point, we've largely ignored the most important part of our programs, the class. Consider the skeleton code. We have public class, something that's the header, and we have this main method. And in the main method, we put some code. At this point, we know that methods are what? Run, meaning that it contains lines of code that will execute when called. But what is the class? Why do we need it? In Java, everything must be inside of a class. A class is a container for variables and methods. The constructs that store data and execute lines of code respectively. You can't have a variable or a method without a class to contain it. However, there is a little more to classes than just containing variables and methods. Classes are an integral part of a programming paradigm called object-oriented programming. A class is essentially a software bundle of variables and methods and can be considered a custom data type. For example, public class person may contain a string for the name and an integer for the age. The person class, not a part of standard Java, is a class we created. It's a new data type and has a string name, integer age, and whatever methods you decide a person should have. In our previous example, we're modeling a person. A person has a name and an age. In that sense, a person will have a name and an age state. The value of this state determines the characteristics of that particular person. The object-oriented programming, or OOP, paradigm attempts to use objects to model things in the real world to solve problems. Person is a type of data, just like an int or a Boolean. The difference is we are saying that what a person is and does. Why am I learning this new stuff? Well, modern software is powerful, user-friendly, and amazingly capable. It is also incredibly complicated. Building Netflix in one class with tens of thousands of lines of code and methods really is not feasible. One of the techniques for managing this complexity is called object-oriented programming. Object-oriented programming, OOP, breaks up a large project into smaller, more portable, and manageable pieces called objects. Multiple objects work together to form a program. In the OOP paradigm, classes are created to define what something is, the variables it declares, and what something does, the methods it declares. Classes are a definition of a type and blueprints for objects. An object will have all the variables and methods of the class, but with actual values for the variables. An object is a specific instance of the class. Imagine that you're writing the code for a very large program, a modern video game. For the entire program, there could be tens, possibly hundreds of thousands of lines of code. Imagine trying to fix that code if something went wrong. In addition, think of all the code you would need to repeat. For example, in a car racing game, you'd have to rewrite all the code for each different car in the game. Continuing with the car racing game example, suppose instead of rewriting the code for every car in the game, you created a generic model for a car. You would define the properties of a car, how it looked, possibly its color, how fast it is, maybe the type of engine, and how much it costs. You'd also define the behaviors or actions of the car. Does it start, accelerate, or brake? Does it turn? Does it use fuel? The previous slide is defining a class. The car class is a generic description of what properties all cars have. In the actual game, a particular car, for example a red Ferrari F12, would be a car object. In other words, a specific car is a car object. The car class is the blueprint for car objects. The car class is an abstraction of something in the real world, a description of what it means to be a car in the context of the game. Summary of OOP. Object-oriented programming, a programming paradigm or technique that uses units of code called objects that work together to create a program. Classes are the blueprints for these objects. OOP uses interacting objects, each with a specific function, to make a program rather than many lines in a single class. Breaking up a large project into smaller units eases testing, debugging, and prevents code duplication in the cases where something needs to be repeated more than once. Just show me an example. Suppose you're writing a program used by your school to track attendance. In this program, it would be useful to have a model of a student. Could you imagine having to rewrite code for 2,100 individual students in your school? The student class would be a description of a student in the context of this program, an abstraction of a real student. What are the important details of a student for this program? Does the color of the student's hair matter? No, it doesn't for this program. What matters is that every student has a name and every student has an ID number. In the case, two students have the same name. These would be variables in a defined student. Our student class so far, it would have a class header, public class student, and it would define these variables, string name, int ID. The above is how we describe a student in the context of this program. It is an abstraction of a student. Obviously, it isn't a real student. What actions could a student perform in this program? These would be the student methods. So we already see that the class is defined as being called student. It's got a string name, an integer for an ID. And then we have public int get number of absences. Of course, we would need a variable to keep track of the number of absences. But we could define a method like this. So a student would be able to get its number of absences. An actual individual student, for example, would be a student object. Below is how student objects would be created. Much more information in future presentations. So student 1 equals new student. Rita is her name, and her student ID number is 123456. Student 2 is Ron, and he has an ID number of 234567. You can see that this is a call to the constructor, and we've seen calls to the constructor before. Classes versus object examples. So you might have a class called teacher, and Mr. Bunn might be an example of a teacher, so that he would be the object. A class might define what a cookie is, but a chocolate chip cookie that you ate is a very specific example of a cookie. A class might be car, but a very specific car might be 2006 red Honda Civic. That would be the object. You might have a student class, and the object that represented you would be the object. You, the programmer, write the code for a class. Then you or other programmers using your class make objects when they're needed to do a job. The student class defines what a student is and does, and a student object would be a specific instance of that class with actual values for the variables, for example, name and grade. Here's another example. It looks like we've got a dog. So a base class might say, the class might say, well, the dog should have these properties. We should know its color, its eye color, its height, its length, its weight. But these are the things that it should do. These would define the methods. The dog could sit, the dog could lay down, the dog could shake, and the dog could come. That is how the class defines what properties and methods or state and behavior that a dog should have. But an object is a very specific dog. This dog's name is Rain. His color is gray, white, and black. His eye colors are blue and brown. He's 18 inches high, 36 inches in length, and 30 pounds in weight. And he can sit, lay down, shake, and come. There is more to OOP. There are many more benefits to object-oriented programming, but they wouldn't all necessarily make sense at this point. If you look online for an introduction to OOP, you'll probably see something about abstraction, encapsulation, inheritance, and polymorphism. We'll talk a bit about abstraction, but the rest of these will make more sense next year in Computer Science A. An excellent OOP analogy. Below is a link to a very comprehensive introductory tutorial on object-oriented programming. Don't fear the OOP. The document has an excellent analogy to accompany the explanations. If you're struggling with the content of this presentation or with the introductory OOP labs, it is strongly suggested that you read this document.